Chateliers principle. Chateliers principle states that if a system is in equilibrium and it is disturbed by a change of temperature or pressure, the system moves in such a way so as to undo that change. Now what does it mean is, supposing I have this system in equilibrium, nitrogen plus hydrogen gives ammonia, and it is in equilibrium, it's a reversible reaction, it comes to a state of equilibrium. That is, the forward reaction is equal to the backward reaction. Now you can see through this reaction that it is an exothermic reaction, it produces heat and also proceeds with decrease in volume, meaning 1 volume of this, 3 volumes of this makes it 4 volumes, and final product is only 2 volumes. So if I want to decrease the volume, I must apply some pressure. So requirement for a forward reaction is high pressure. If I want to make ammonia, I must give high pressure. Heat is being produced during the reaction, so low temperature can be favorable for a forward reaction. So when we look at an equation, from the equation we get to know whether we need low temperature, whether we need high temperature. So since I need low temperature, then the reaction is going to move in the forward direction. Now supposing this whole thing is in equilibrium, in the state of equilibrium, and I now try and change the temperature and pressure. So if it requires low temperature, but if I supposing start heating it, that means the reaction will start moving in the opposite direction so that it can change that, so that it moves in a way to undo this change. I have changed the temperature from low to high temperature. The reaction wants low temperature, so it will start moving in the opposite direction. Because in a reversible reaction, the opposite direction, ammonia plus heat gives this and this, meaning this requires heat. This does not require heat. Forward direction does not require heat, but the backward reaction requires heat. So if I start increasing the temperature, my reaction will move in the backward direction instead of moving in the forward direction. Similarly, the whole reaction in the forward direction requires high pressure because 4 volumes are changing into 2 volumes. So high pressure is required. But if I make this pressure low, reaction will start moving from the opposite direction. That is, ammonia will start changing into nitrogen and hydrogen. 2 volumes will expand and change into 4 volumes if I make the pressure low. So whatever is the requirement for a particular reaction, forward or backward, if that is given, then the reaction proceeds that way. If I start disturbing that equilibrium, reaction starts changing its course, that is, it tries to change that and finally again come back into equilibrium. So it is trying to undo that change and come back to equilibrium again. See another reaction. Now in this reaction, N2 plus O2 plus heat gives you 2NO, which means it is an endothermic reaction. And volume is the same because there are 2 moles here and give you 2 moles in the product. So the reaction is endothermic. So if I keep on giving heat to it, it requires heat, more of nitric oxide will be formed. And in the opposite direction, you can see 2NO gives N2 plus O2 plus heat, meaning from here to here it is an exothermic reaction. So this side it requires heat. Backward reaction does not require heat. So backward reaction will take place at low temperature. Forward direction reaction will take place at high temperature. More and more nitric oxide will be formed if I have high temperature. Plus, if I increase the concentration of nitrogen and oxygen, concentration of these are increased, product will be formed. Concentration of NO is increased, reactants will be formed. And there will be no effect of pressure here because the number of moles here and here are same. So it does not matter if I increase the pressure or decrease the pressure. So it will be ineffective in presence of pressure, but the reaction is determined with the help of temperature. 2SO2 plus O2 gives 2SO3. This is a part of contact process to prepare or manufacture sulfuric acid. So we have taken here 2 plus 1, 3 volumes of the reactant which change into 2 volumes of the product, plus large amount of heat is produced. This shows that the reaction is an exothermic reaction. On its own, heat is being produced in this reaction. So you have, I think, learnt in class 10 also that the catalyst in this is vanadium pentoxide, which is preheated, and after that external source of heat is removed because heat is produced during the reaction. So if the reaction already has heat, we don't need to supply any more heat. So if I want to make the reaction move in the forward direction, I must give it low temperature because already heat is being produced in this reaction. The volume is decreasing, that means I must apply some pressure on it, and to apply some pressure meaning I need to have high pressure on it. So if I want to have the forward reaction, I must have low temperature and high pressure. If I want the reaction to proceed in the backward direction, the backward direction reaction is an endothermic reaction, 2SO3 plus heat, meaning that is an endothermic reaction giving me the reactants. So now requirement for a backward reaction is high temperature and low pressure so that the volume increases from 2 volumes to 3 volumes.